Elfinwood Data Science Blog. Elfinwood Data Science Blog is associated with Elfinwood Ecology, which is focused on data science, ecology, and conservation, and is based in Washington's Methow Valley. To get to Elfinwood Data Science Blog, you can go to elfinwoodecology.org and click on the blog here. And you can see the lessons down below. Elfinwood Data Science Blog is associated with a GitHub repository called Elfinwood Data Sci, Learning Data Science. And in here you can find the lessons, each of the files for each of the lessons. And we'll be covering the file here in lesson 8, which is the second of 2 lessons on SQL select statements. So in this lesson, which you can read more about in more detail on the blog, we go through examples of select statements, and we're going to cover limit and offset, aliases, data type casting, creating columns on the fly, and mathematical operations. And if you're watching this video, then you're probably aware of the Elfinwood Ecology YouTube channel, but if not, please subscribe to Elfinwood Ecology on YouTube and get the latest updates as more lessons are posted. So in this lesson, we'll be working in pgadmin in my first database. And so if you've followed along so far with the blog and you've been working on the lessons on your own computer, then go ahead and connect to my first database, and you can run through these SQL select statements on your own as you watch the video. And if not, we'll just jump right into this annotated SQL file here and look at some examples. This is lesson 8 again, and at the top of the file are instructions for using this file. This is a series of select statements that are commented out using multi-line comments, and a multi-line comment is sandwiched between slashes and asterisks like this. And to run each of these select statements, you'll remove the slashes and asterisks here. That is now uncommented, and you can now run this SQL select statement. To run the next, you'll comment out the one you're currently on, and then do the same for the next. So you can now run the next one. So let's start at number 1 here. And we're going to talk first about limit and offset. So limit is an optional clause within a select statement that allows you to control the number of rows that are returned in your select. And so it's placed after the order by clause. And in this case, we're going to limit the results to only 10 rows. So we'll run that. And so we've got our 10 rows. But it's really important to think about the order in which the results are returned. That's going to dictate what data is returned to you. And so in this case, we've ordered by sample ID here, ordered by sample ID ascending. And so it's going to return the first 10 rows, and the results are going to be based on the alphabetical order of the sample ID. So these are the first 10 in alphabetical order. But let's say that you are interested in looking at the first 10 plots with the earliest sample times. So in this case, you'd have to order by the site start TS, which is TS stands for timestamp. And so you'd want to order in chronological order, which would be in ascending order. And so this next example here, number 2, we've done that. So we're going to same limit, number of rows here, 10 rows. In this case, we're ordering by site start TS, and you can see that now it's returned a different set of data, which are the first 10 plots that were sampled in chronological order. If you put 0 after limit, you will get no rows, is what you might expect. All right, well, let's look at one more example here of limit. and that is, let's say we wanted to look at the 10 plots with the steepest slopes. And so in this case, we'd have to order the results by slope percent in descending order. We want from greatest to smallest, and that's what we've done here. So that returns the first the 10 plots with the steepest slopes. And then further, we've also next ordered by sample ID, so that if you have ties, like in this case you've got a tie in your slope between these three plots, the results will then be returned by sample ID in alphabetical order. All right, offset is used with limit to specify the number of rows that are skipped before the limit clause takes effect. And so, to back up just a little bit, it's important to think about the order at which these SQL statements are evaluated. And you can look at the blog post for more details, but in short, the limit is applied after the order by. And so that's why the order by is important. In this case, offset is applied before limit, and so you're gonna what offset will do is it will specifies the number of rows that are skipped before limit takes effect. So in this example, we're gonna limit our results to 10 rows as we've been doing, but we're gonna offset by 5 rows. And so what this will do is skip the first 5 rows and return the results starting with the 6th row, 10 rows starting with the 6th row. So this is similar to the previous statement, except we're skipping the first 5 rows. And so you can see that it's now starting with the 6th row here. All right, moving on to aliases. Aliases are useful for a couple of reasons, and what aliases are just temporary column names that last as long as for the duration of the SQL statement that you're running. So they're useful for shortening column names, which can help shorten sort of the length of complex SQL statements. They can help save time with typing because you can temporarily assign a shorter column name. Or you can create more meaningful column names for, say, reporting or something like that. And it's really handy because what it allows you to do is use column names that follow the best practices for database objects in SQL in your database, but in the results of your queries, you can be more creative or provide more meaningful column names that are useful. So for example, in this case, this is an example of shortening a column name. We're going to use the as keyword is used to assign aliases. In this case, we're assigning site start TS as ST. So we're going to use an abbreviation of site start time or start time. And you'll see that in the result, instead of the column being named site start TS, it's called ST. Notice, however, that in the order by clause, we use the actual column name here, site start TS. And this is related to the order in which SQL statements are evaluated. So the aliases are applied after order by, and so in this case, there's no recognition of ST before the order by clause happens, so you use the full column name. Another example here, using the, as I mentioned above, you can, as keyword is used to create aliases, but the as keyword is optional. So in this case, we're saying you can just put a space after the column name and then type out the alias. In this case, site start TS space ST, and this will be the same result. It's a little more succinct. It's kind of your preference whether you want to use the as or not, but you get the same result. Okay, as I mentioned earlier, aliases are also useful for temporarily providing more meaningful column names. And this might be handy if the results of a query will be used in a report table. So in the following select statement here, we're using a alias that's a little more intuitive. So instead, we're going to use plot start time. We've got capital letters and spaces, and this would be a more appropriate column name for a report table, for instance. So there we go. You can see plot start time is the alias. So note the use of the double quotes. And so double quotes are necessary if for aliases or column names if you are going to include spaces, if you want capital letters to be included in your column names, or if you want to start the column with a number. So let's just look at a couple different examples where we don't use the double quotes. We're going to get an error, so it doesn't like that. We can also get rid of the spaces and like it because of the spaces, because you haven't used double quotes. So let's try it again. So this worked, except you don't get the capital letters in there. It makes them all lowercase. And then we can also start it with a number here. And that's another error. It doesn't like that without the double quotes. But let's say put the double quotes back, and that works just fine. You can have put whatever you want in between double quotes for your column names, even if it's nonsensical or what have you. So again, we're going to go back to our original alias, and that works just fine. Okay, so now moving on to data type casting. So data type casting is a means by which to temporarily change the data type of an existing column in the output of a select statement. And so, for instance, we can select, in this select statement here, we're selecting sample ID, site pH in its original data type. And then we're going to cast site pH to an integer, and we're going to use an alias, site pH integer. So we see we've got the result here. There's site pH in its original data type, and then here's site pH integer, which we created here by casting to integer. And note that the result is, of course, rounded to the nearest integer, as you'd expect. So let's look at another example where we're casting a numeric type to a text data type. And that's fine. Again, we've selected site pH, sample ID site pH in its original data type of numeric, and then site pH as a text and data type, and given it an alias of site pH text. And we see that it works just fine. And so one thing to keep in mind is that casting only works if the data in the column is compatible with the data type. And so just about any data type can be cast to text, but not all data types can be cast to an integer or numeric. That'll only work if all of the data in a column is actually a number. And so in this example, it fails, the casting fails, where we're casting the site field note column to numeric because there's a bunch of text in there. It's not all numbers. So here's the site field note from the previous query result. So let's see what happens. Yes, we get an error, invalid input syntax for type numeric. So bear that in mind as you're using casting. All right, one of the interesting things about SQL is that you can create columns on the fly, and you can even do this without specifying a table expression. So in this example, I'm selecting this expression here and casting it to text and giving it an alias of new column. And I'm not specifying from any table. I can just select that. And there it is, new column. I just created this column. Another example is using a function, a date-time function called now. And what now does is retrieve the current system date and time. And so we're going to select now as current timestamp. This is the alias, current timestamp. And there we go. That's the time right now based off my computer system. Okay, and so you can, as I mentioned, you can create columns on the fly with or without table expressions. So this example shows creating a column on the fly with a table expression. So in this case, we're selecting study value, sample ID, site start TS, and creating this column here. It's a Boolean column. We're assigning the value of true, casting to Boolean, and creating an alias column created on the fly from the public.site table. Oops, didn't like I had that highlighted. Okay. Yes, so you can see here, here's the column we created, column created on the fly, and just note that when you're creating a column on the fly with a site table expression, that the value will be returned for each row that's returned in the query. So in this case, it's true for every row in the result. All right, lastly, we're going to go into mathematical operations. And so in SQL, you can perform math on a single column. You can perform math between columns. And the result is a column created on the fly. So for example, in this example here, 14, we're performing addition on a single column. So we're going to select unique ID. We're going to select unique ID plus 1 and give it a alias of unique ID plus 1 from the site table. So we've got our unique ID, and then we've got unique ID plus 1. And so the math is applied on a row-by-row basis. Here's another example. Performing multiplication. And so in this case, similar to above, we selected unique ID, we selected unique ID times 1.543, and gave it an alias of unique ID plus 1 again. We're going to change that to times 1. And we're going to run that. And so you can see, similar to above, we have unique ID, and then we have the unique ID column with the math applied, and this time unique ID times 1. And note that it was originally an integer data type, but because it's multiplied by a numeric value with 3 decimal places, the result, the product is a numeric data type. And then one last example where we're performing multiplication between columns. In this case, we're selecting unique ID, surface organic thickness, and then unique ID times 1.543 as above, and then multiplying that by surface organic thick centimeters. And we're going to give it an alias of rubbish and hogwash, because this really is a nonsensical value here that we're going to produce, but for the purposes of this example, it works well. And so note also that when you're performing math in SQL, you're going to use the similar standard mathematical notation with your parentheses and all that. So give the result here, our surface organic thickness, and then our rubbish and hogwash column, which is the product of our multiplication. So for more details, please see the blog post for lesson 8 on elfinwoodecology.org in the blog. And thanks for joining us today.